It's my great pleasure to start proceedings this morning with an outline of what we're calling the Liberty program. Liberty is not just a specific marine reactor that's being developed. It's not one particular type of floating asset, and it's not different individual elements such as a nuclear shipyard or a specific training program. Liberty is the whole package. It's a complete maritime civil nuclear program encompassing technology, regulations, and market building in an entirely holistic fashion from start to finish for commercial maritime nuclear. Hopefully, as we can demonstrate, it's a very pragmatic way of how we approach maritime nuclear getting deployed, because it's not just about the technology, it's about how we create the conditions for that technology to function inside a complete ecosystem. So Core Power's mission is to deliver this whole program. We've made a lot of progress over the last few years. And for those who maybe haven't been to one of our summits before, and just to build quickly on what Charlotte was saying, I want to very briefly talk you through who we are, what we do, and how we approach this. Core Power is a private company, just over 6 years old, and we're supported now by nearly 70 shareholders from the global shipping industry. They're some of the large ship owners, they are major shipyards, they are the shipping banks, they are the big trading houses, cargo interests, and they are the family offices that have dealt with the global fleet through generations. So these are long view investors, and they're looking for the next stage of this industry. Now, we're calling this the Liberty program because this is the thing that will set the market free, set the supply chains and the logistics free from some of the constraints and the challenges that are now piling up around this sector. And maybe just a quick aside on the name Liberty. I think there's a small but important distinction between freedom and liberty. If freedom is the general state of not being constrained, then liberty is the recognized right to act in specific ways. We're only at liberty to do things when we have permission or entitlement to act within a specific framework, be that a social framework or a legal framework. But I think in this context, it means the framework which is now emerging along with this hybrid industry of maritime and nuclear. And I'm going to talk a little bit more about that later on. But we're pursuing this because the size of the prize really is quite something. We've identified between now and 2060 a $5.6 trillion market opportunity in supply chain integration, in manufacturing, in operations, and in sales. Now, the way we achieve this is really by combining the best of what the maritime world has to offer with the magic of new nuclear. So that's sort of the headline on this, if you like, and that creates two massive opportunities in the market that we can start filling with these technologies. However, in order to be able to scale difficult and complex new tech and these constructions into the market, we must move to modularity. Modularity is the solution, and certain top-tier shipyards around the world are experts at this. And we're starting to build those critical partnerships in this area because it's really through those partnerships that we'll be able to create the platform and the base for scalability. So the two opportunities then, again, that Charlotte outlined for these products or business cases are FNPPs and nuclear-powered ships. They're two distinct, separate sectors, but they have common engineering and common technology in the middle, using these shipyard manufacturing techniques to deliver nuclear on time and on budget to industrial customers. The ability to create that fleet of energy-resilient, nuclear-powered ships will change the value chains of global trade and how we move things around. The timeline for all of this, an order book is in the process of being formed, really starts to materialize and gets announced from around 2028 onwards. The delivery then of that order book is something that will take a little time. Bureaucracy is one of the things that can kind of stand in the way of new developments here. From around the early to mid-30s, we expect to see that scaling of this new technology moving forward. But let's start with floating nuclear power plants. People talk about them increasingly now, but what do they really look like? I think they can look like an awful lot of different things, but they're actually quite small. Here you can see a rendering of a floating nuclear power plant delivering about 70 to 80 megawatts electric from a single reactor straight to shore. Sitting in a port, this would be around 160 meters LOA. It's got about a 35-meter beam and a 6 to 7 meter draft, and it displaces about 25,000 tons. So in the grand scheme of things, it's pretty small, and it can sit securely in a sheltered location providing that resilient energy direct to customers. This is something that can be delivered on time, a specific date, and an agreed price directly to a customer. There are hundreds of ports around the world that need to electrify in the next 10 years. And here's a solution that fits really well with a small footprint and really very little environmental impact at all. This is a huge market between now and 2060. The Russians are already doing it. And as Charlotte highlighted, it was done in the West as far back as the 1960s. So we know it works really well. But I think it's worth going back over the reason why these FNPPs, or floating nuclear power plants, are so critical. And it really comes down to a few things. How do you buy nuclear unless you're a regulated utility with a specific land authorization and the experience to build nuclear power plants? How do you actually get this stuff? How do big data companies, the AI hyperscalers we heard about, how does oil and gas, how does manufacturing and heavy industry get nuclear? Well, at the moment, they have to get it from their utility. But with this new asset class, here is an opportunity to partner with those utilities, or even create the opportunity themselves to operate small modular nuclear power plants delivered on time and delivered on budget. Because it's small modular reactors, which is what everyone talks about. But the reactors themselves are always small and they're always modular. The hard thing about nuclear is delivering the whole power plant. So we think it's less about small modular reactors and more about small modular power plants that can be delivered as a full product, like you would deliver an aircraft, like you deliver a complex piece of machinery that's serially produced as a product to market and not as a one-off mega infrastructure project. So all these power plants are quite small and they can be swapped. The majority of human activity does happen on the coast, and that's really where the market opportunity for this comes from. If you take the OECD with the United States as the likely starting point, you take the UK, the Nordics, parts of the EU, the Middle East and parts of Asia, you've got a large market of opportunity here that can then be scaled beyond that as we go. Now, nuclear-powered ships. Nuclear-powered ships are a little bit more complex in the sense that, of course, unlike FNPPs, they're completely mobile. And mobile reactors is a hard thing to do when you don't have the backing of a national state behind you. But that's what's now being unlocked, and that's what's starting to change with this new market. But the environmental impact of shipping is really only one aspect of this, however. If it's just about decarbonisation, we can move entirely down the road of using low-carbon synthetic fuels, but it's looking increasingly likely that the economics of these doesn't really stack up. Slower ships carrying less cargo at a much higher cost will put immense pressure on our seafarers and on our workforce and make the industry less secure. That is not really progress. Shipping needs not only an economic solution, but also something that can improve the effectiveness of our energy use. And the only thing that can do that and can compete with the reliability of fossil fuels is nuclear energy. It's the only power source that can give us that massive energy density that we need for these large ships with true zero emissions. And from 2035 onwards, there are 12,500 of these biggest vessels that must be replaced due to old age, and those replacements cannot be emitting. So the most viable way for this tonnage class is nuclear. So we need that new nuclear technology to be developed that unlocks the market and creates that new sector. If you take those 12,500 large vessels, of that group, as we heard earlier, it's 7,000 ships only out of the global fleet that consume the majority of marine fuels burned in the world today. Those are the largest box ships, they're the largest bulk carriers, tankers, car carriers, etc. It's only around 7,000 ships. If we can replace those by 2040 or soon after, and there's a very large proportion of them that will have to be replaced, then we have that potentially large market for propulsion. We know that nuclear works really well at sea. It's been demonstrated by the naval nuclear propulsion program since the 1950s. It's really a perfect solution, but the problem we have is that the technologies that are used by the Navy, the ones that are used in certain submarines and certain aircraft carriers, cannot be used in the commercial market. And it's not because of safety, it's not because of public concerns, it's not because of the potential for some environmental disaster around them, it's because we can't insure them. It's really as simple as that. We cannot insure a commercial vessel powered by a naval reactor when it goes into a port. So what we need is the new technology that we can commercially insure on a mobile platform that then moves in and out of the jurisdictions of the countries that are prepared to take them, and with those countries as signatories to a liability convention that's starting to be developed. But in order to do that, and in order to convince the entire market, all the ports, all the people and coastal stakeholders in this, that we have the means to be able to create the condition for that insurable technology and deploy it where we want to deploy it, we must have an end-to-end quality program. And that's what we're setting out now, the Liberty program. It's cradle to grave from R&D all the way through to decommissioning. The highest quality standards, the highest safety standards, the highest standards of integrity in every single aspect of this is going to be crucial. Because if we look over that fence to the naval nuclear propulsion program, it is the gold standard of quality. It is the one that embodies safety, and has a deeply ingrained culture of professionalism that encompasses every single aspect of technology development, of engineering, of building, operating, servicing, and eventually decommissioning. And that's something that we absolutely have to emulate on the civilian side. So there needs to be that clear demarcation, I think, where you have that strong fence in the middle, with military on one side, civilian or commercial on the other, but the safety and the quality standards for both are very much the same, and they come from the same point. We also need that regulatory framework. That's happening already. There are panels that will go into more detail on this later on. And we need a social contract with the public around those regulatory standards and that end-to-end quality regime. But it's really the integrity of the program that creates the conditions for that social contract. We don't have to convince absolutely everyone that we can do this, but we do have to convince those that are where this starts. So that's the ports that will take the first ships, the nuclear corridors that will likely emerge in which they will trade, the customers that will use them, and the receivers that will take the cargoes that come off these vessels. So that's really the two key things to solve. It's insurance and it's social contract. But there are other criteria as well. And when we look at how to meet the handful of key criteria for commercial maritime nuclear, there are really only about 5 technologies available to us. From left to right in this chart, we have the advanced light water reactor, the naval reactor, if you like. We have lead-cooled fast reactors, high-temperature gas reactors, heat pipe reactors, and molten salt reactors. And if we apply those criteria that we've consistently outlined, that's the insurance criteria, safeguards criteria, safety criteria, and the economic criteria across the characteristics of these different technologies, you can see that the further you go to the right, the better that fit is. And we see that the reactors that are operated by some of the world's navies, perfect as they are for those navies, cannot be used commercially. And you can see that they don't meet hardly any of the criteria that we need for commercial maritime. Lead-cooled fast reactors, not a great deal better. High-temperature gas ticks more boxes, and we're getting there. Heat pipe reactors, we're almost there. It's a great new way of doing it, and we think there'll be plenty of use cases for them on compact floating systems in ports, like you saw earlier, and for coastal industry. But for those largest power requirements on the biggest vessels, they tend to come up a little small. And then you've got the molten salt reactors on the far right-hand side, and particularly the fast spectrum molten salt reactor, which meets all the criteria almost perfectly. It's a liquid-fueled reactor operating in the fast spectrum, low pressure, which leads to a small emergency planning zone, which you'll hear more about, and with a 20-plus year fuel cycle. And there's many other criteria you can apply as well, but really looking at this from a sort of logical technology perspective, this is likely the way that we get there. And we're going to hear more about the developments for both the heat pipe and molten salt reactors later on today, so I won't go into any more detail here. But onto the Liberty program, which comes actually in 3 phases. The first phase of this program is technology development, it's product development, and bringing that to market through licensing. As you can see in the central section here, you have that common technology for both asset types sitting right in the middle of this. But it's not just about the actual reactors, it's about the interfaces for them, it's about the solutions design, it's about the power conversion system, and it's the whole packaging of that technology then, so that you can lift it in and out as an entire power pack into floating nuclear power plants and nuclear ships. On the left, on the propulsion side, there are 3 key things we need to solve. We need to solve getting access to ports, and we do that through insurability. This will ultimately be technology-led, and it will need to be confirmed and ratified by regulators through the licensing process but the goal here is a much reduced emergency planning zone, which enables the insurability of ships in ports. The second important thing is export controls. We have had, as a result of the only existing nuclear propulsion program being the naval one, things have primarily been under military export controls. So we need to see that separation between military and civilian, so that maritime civil nuclear propulsion sits on the commercial side under the Department of Commerce and not on the military side under the Department of Defense. And the third thing, of course, is safeguards, which is absolutely crucial, and I'm going to come on to that in just a moment. Then for floating nuclear power plants, on the right-hand side, the three critical things we need to be able to solve there is we need to be able to prove that reliability to achieve the localized energy security that we're promising, so that whatever the weather, the customer has that power that he needs. Data centers, for example, need what they call 5 nines reliability, 99.999% uptime. We need to be able to show time and economics that we can deliver at the price that we've said we would. And again, modular construction is the way that we get there. And of course, scalability. Can we keep making the same product again and again in large numbers and getting better at it? Better quality assurance, a faster learning curve, and creating a better product each time, like we do with anything that we really make in a mass assembled environment today. Can we do that with nuclear power plants? Well, we believe, yes, we can, and this is the way that we can do it. But I want to touch on something now that's going to be fundamentally important, and that is the role of the flag state in all this, because this really is crucial. The introduction of nuclear-powered ships into service, we believe, will follow a very specific pattern that allows that formation of bilateral liability agreements between states. It's essential to recognize that a particular framework or pattern emerges when we join the maritime safety and security frameworks of prominent IMO member states with those of the nuclear industry in those countries. This is because by introducing civil maritime nuclear propulsion to shipping, we're bringing nuclear licensing to maritime. And that dramatically expands the role of the flag state. And I think this is the framework that I hinted at right at the start, in which we have the freedom, the liberty to act and develop. The nuclear licensing authority of a member state only has legal jurisdiction in that country, but that logically also extends to ships flying that flag. As a result, a marine reactor that's licensed here in the UK, for example, will need to be installed on a UK flag vessel operated by an organisation that's approved and licensed in the UK. That vessel and all of her installations, which includes the reactor itself, the systems, and the nuclear fuel, will then remain under UK jurisdiction wherever that vessel is, whether it's far from home, transiting the oceans, entering waterways of foreign countries, or calling at overseas ports. That vessel then cannot change flag without specific approval, or the operator loses its license to operate, and the ship itself would then lose classification. And in fact, the flag state's role is even further expanded in all this, because the nuclear regulator, of course, imposes additional requirements. A fundamental one of these is safeguards, which is the inventory control of nuclear fuel. Nuclear fuels are always subject to safeguards control. And all member states of the International Atomic Energy Agency must comply with IAEA safeguards and inspection regimes. All operators are required to account for their fuel inventory on board and in the reactor to a very great degree of accuracy. Agency inspectors have the right to verify that systems and seals are intact and that nuclear fuel inventory hasn't changed. Inspections then can be coordinated in the future between the Agency Safeguards Authority, Port State Control, and very likely also involving classification societies. So putting all this together then, we see that the emergence of fleets of nuclear-powered ships will fly the flag of that country where the reactor originates. So US reactors on US flagships, UK reactors on UK flagships, French reactors on French flagships, Russian on Russian, Chinese on Chinese, etc. Now, very few countries actually have nuclear reactor development programs, and even fewer have programs aimed at the maritime sector. This may change in the future as new nuclear for maritime kind of inevitably becomes more mainstream. But I think the important thing to take away is this market requires significant coordination and collaboration between both the maritime and nuclear regulators. And once a country develops a nuclear fleet to fly that country's flag, The diplomatic mission then needs to set to work with other nations with which it has a significant amount of maritime trade to agree on a mutually acceptable liability regime under which the commercial insurance industry can then develop and operate. But you're going to hear more about that work after the break. Okay, then phase 2 of the program. So if you see those grayed out boxes at the bottom there, they follow through into phase 2. Once that product has been brought to market, it's really then building out the supply chain and the workforce. And that work has already started, or at least creating the conditions for this to happen. It's making sure as well that the final parts of the regulations come together so that we can then set up the manufacturing base. That's the shipyard that's going to fit out these FNPPs and these vessels. It's about how we finance this. It could be through export credit guarantees, it could be through bank equity, so bank debt or equity, and also how the financing of any joint venture type arrangements could work. There's a large-scale amount of funding both available and also that has to be organised into each one of these. And of course the workforce, setting up that program of education and of training, not just to the seafarers and other crew members, but those that are going to be the engineers, the managers, and the operators of the various technologies that we have here. We believe this is a career opportunity for a new generation of STEM students and engineers to come into a market of potentially high impact. And there'll be a panel, again, just before lunch that looks at this in more detail. Regulations, well, that's something that's sometimes a little bit out of our hands, but what we've been involved in, instead of trying to influence regulations on our own as a private company, we've been part of setting up and joining forces with other companies in the market and through an NGO called NEMO that Charlotte highlighted, Nuclear Energy Maritime Organization. It's had a strong first year in operation in the process of getting NGO status at the 2 critical UN agencies that manage the regulations for nuclear and maritime. And again, you'll hear more from NEMO and some of its members later. But that factory, that home yard, the place that we will set this up is the one where ideally we'll have the manufacturing of the reactors, including potentially synthesis of the fuel, and the creation and the fitting out of that power pack that I mentioned that gets installed in both the ships and the FNPPs. Units without the power packs could be manufactured and put together in shipyards overseas, at least initially. So Korea, Japan, potentially some European yards would be involved in this, and those dumb assets, if you like, would then be towed or brought over by heavy lift vessel to the home yard. And it's there that they're placed under licensing and regulations in that country. So if it's in the United States, a US flag we put on those ships, and NRC licensing would be done for those and the FNPPs, and they'll then be moved out from there. That's also where they'll come back to. This yard is where the assets will return for refueling, for maintenance, for repairs, servicing, and eventually also for decommissioning. Now for the floating nuclear power sector particularly, this could be the home port for an entire fleet of FNPPs that can operate in other places around the area where that yard is located, and they can actually just simply be replaced instead of being refueled where they're working or where they're located. This is kind of fleet optimization of nuclear power in a completely different way than we've thought about it before. Okay, phase 3. These assets are getting built, they're getting out into the market, and we're now got the workforce to an appropriate stage of development, and the customers are now stepping forward. Customers will be able to take either a lease on a nuclear-powered ship, so it would be controlled by a special purpose vehicle, an SPV, made up of a set of investors that are sitting there also as part of the program, if you like, and then leased out to customers. There could be the big container shipping lines, large tanker companies, the big grain houses, etc., can lease these ships over the longer term, or they can be operated in a joint venture. And here you're starting to get more into perhaps specific cargo operations. Say you have a mining company on one side, a steel mill on the other. You've got a supply chain then of iron ore moving between them, and you can then set up that joint venture with the shipper and the receiver using that value chain of the commodity, where really the ship just sits and operates in the middle as the conveyor belt between the two. Floating nuclear power plants, it's the same thing. You can sell them to an appropriate utility. You can lease them out. You can operate them in a joint venture with a customer. Each particular project solution has an element of tailoring to it, depending on what the customer needs. And on the financial potential of those SPVs that owns each one of the units, Again, it's also depending on the individual customer. They could be tranched through equity, through debt, through financing provided by export credit agencies, etc. So there's a lot here. We now see the customer base starting to step up and say, okay, how does this apply to us? How do we do this? How do we get the contracting strategy in place to do it and do it potentially in several locations? Okay, I'm conscious of time. As I said, a lot of these themes are going to be picked up by later panels, so I'm going to stop there, but I hope that was a reasonable overview of what the Liberty Blueprint looks like. And with that, ladies and gentlemen, I'm going to say thank you very much for listening and hand you back to Charlotte.